What's up, guys? Welcome back to the channel. Today on this video we'll be doing this question paper that you see here. As you can see, this is National Certificate for Mathematics in 3, and this question paper was actually written on the 26th of November 2025. It was an X paper which took 3 hours. So on this particular video we're going to focus only on question 2. Just in case you want to watch question 1, I will leave a video on the description, and also the very same video of the question 1 of this question paper will pop up on the top right of this video that you're watching right now. Now, before we start though, I will also gonna leave timestamps for each and every question, just in case you want to watch a question directly, not in a sequence order. Alright guys, before we look at question 2, I'd just like to say thank you very much guys for watching, subscribing to the channel, also commenting on the channel. If you haven't subscribed, subscribe to the channel. Make sure that you hit the bell notification so that whenever I upload a new video, you get notified. Okay people, let's look at question 2 and let's solve it. Alright, here is our question 2. Now question 2, it's solving for x. As you can see there, the one has to solve for x. So we have only 2 questions. One of the questions is exponents and the other one is logs. So we're gonna do 2.1. So let's create space and then let's do 2.1. Let's look at 2.1. As you can see, 2.1, like I said, they want us to solve for x on this question 2. Now 2.1 is actually exponents, so we need to simplify this to a point where we can able to solve for x. All right, so let's look at the first term there on the left hand side. So we need to change this base here, which is 4, in terms of 2. So here's how we're going to do it. We're going to have 2 to the power of 2 there. 2 to the power of 2, it's actually 4. So we put it inside the bracket. Please don't forget to put it inside the bracket. Then you're going to write the exponents there, which is x plus 1. So x plus 1. So this here still the same as the first term. So we go to the second term, which is this one here. So this one, we're just going to rewrite it as it is. As you can see, the base here is 2, right? And then we have the exponent of 2x plus 1. There we go. Now let's go to the third term. As you can see, the third term here, with fraction there, we have 1 over 4. And then all of this, they have the power of negative x. So this one here, you can rewrite it like this. You can say 4 over 1 to the power of positive x. All right, people, if you get confused here, this is just the law that we use on exponents. This law here states that if you change the sign of the exponent, the numerator is going to become a denominator and the denominator becomes a numerator. So basically what's happening here, this one goes to the denominator, as you can see there, and then the 4 go to the numerator, as you can see there, right? So I hope you can see this. This is the law. Just in case you don't know about the law, I will leave a video that explain this law, including the laws that I'm going to use on these other terms that we just simplified. I'm going to leave that video in the description, and also the very same video will pop up on the top right of this video that you're watching right now. So let's look at the right hand side. We have 7 over 16 there. Right, now let's look at the first term. Going back on the left hand side, we have 2 to the power of 2. This exponent here, this 2 is going to multiply x plus 1 because we have the bracket there. Again, that video that I just put on the description explains this law there. So we're going to have 2 to the power of 2x plus 2, because if you multiply this 2 with x, it's going to give you 2x, and multiply this 2 with 1, it's going to give you that one there. Okay, let's continue. Then plus. So for the second term, again, don't do anything at the moment, just rewrite it as it is. 2 to the power of 2x plus 1 plus. Now the third term on the left hand side, we have 4 over 1 to the power of x. So what we can do here, we can change this 4 in terms of 2. So we can say 2 to the power of 2. Then outside there we have x. Guys, even if you don't write this one, it's okay. Anything divided by 1, it is that thing. Then we equate this. There we go. Then from here, guys, from here we can start separating these. Like I said, guys, again, I've made a video explaining how to separate this. I am gonna leave it at the top of this video that you're watching here, and also on the description as well. All right, so there is this law here. It states that when the base are the same and multiplying each other, the exponent, they actually add, right? So we have to reverse this because this here is the same as that too. So we need to reverse that. So let's do it. So as you can see, we can write this as 2 to the power of 2x multiplied by 2 to the power of 2. Remember, I did mention that when the base are the same, you can do this. Okay, you can add the exponent there. Right, so we are going backwards. So the base are the same. These exponents can add and give you 2x plus 2. I hope you understand that, guys. All right, plus. Now we do the same thing on this one as well. We have 2 to the power of 2x multiplied by 2 to the power of 1 plus. And then the last term on the left hand side, we just multiply these two and that x there because they're both exponents. Remember, we have brackets there. So we have 2 to the power of 2x. All this is equaling to 7 over 16. There we go. Now, as you can see, we have three terms on the left hand side. Let me just highlight them very quickly. So 1, 2, and 3. So within these three terms, on the last step here, there is a common factor. Our common factor here, it's actually 2 to the power of 2x, 2 to the power of 2x, 2 to the power of 2x. So we need to take that common factor out. So let's start on the first term there. If you take out 2 to the power of 2x, we'll be left with 2 to the power of 2, this one here. There we go. And then plus. Now we come to this term. There we go. If you take out 2 to the power of 2x, we're only going to be left with 2 to the power of 1. Right, now we come to this one here, the third term on the left hand side. If you take out 2 to the power of 2x, remember we have plus here, this is going to be 1. We left with 1. All this is equaling to 7 over 16. There we go. I hope you guys understand. Just in case you don't understand, leave a comment on the comment section. So let's create a bit of space here so that we can continue with our problem. So inside the bracket there, on the left hand side, let's first write this 2 to the power of 2x. Then inside the bracket, we have 2 to the power of 2, which is 4, plus 2, which is 6, plus 1, which is 7. There we go. And then this here is equaling to 7 divided by 16. Remember, we are solving for x using exponents. We need to divide by this 7 here. Right. Remember, these are multiplying each other. So if you divide by 7, what you do on the left hand side, you must also do on the right hand side. So even here, we must multiply by 1 over 7, which is the same as dividing by 7. So if you divide by 7, 7 and 7, they will divide each other. You're going to be left with only 2 to the power of 2x. There we go. Then on the right hand side, you're going to be left with 7 divided by 7, multiplied by 1 over 16. So you're going to be left with 1 over 16. There we go. So this is what we're left with. We are not done yet. We need to deal with the right hand side. So let's look at our problem. I'm going to continue here. There we go. So we write 2 to the power of 2x, which is this one here. And then we can rewrite 1 over 16 in this manner. We can say 1 over 2 to the power of 4. Remember, 2 to the power of 4 is the same as 16. Now, what shall we do here? So what we can do here, we can also rewrite the left-hand side, which is 2 to the power of 2x, which is equaling to. Now, we can take this 2 to the numerator, the base there. And then when we do that, this 4 becomes negative, the exponent. So since we have 2 as the base for both sides, we can just drop the base and focus on the exponents. So we're dropping this base, we're going to write 2x, which is the exponent there, right? Which is going to be equaling to negative 4, which is the exponent there, right? So since the base are the same, you're allowed to do what I just did on this step here. So we divide by 2 throughout, divide by 2. On the left hand side, we're going to be left with x, and on the right hand side, we're going to be left with negative 2. So this is our answer. So our final answer, x is equaling to negative 2. Let me just zoom down a bit so that we can able to see the question. There we go. Guys, I hope you understood this because it's really not that difficult, people. It's just that it needs you to understand your exponent. All right, people, if you have any questions concerning this problem that we just did here, please do not forget to write on the comments, or you can rewatch at the point where you get lost before you write on the comment. But if that doesn't help, you can always comment and I'll try to answer you to my level best. Again, if you haven't subscribed to the channel, subscribe to the channel because you are missing out. Every time when I upload, you will be notified as long as you subscribe. All right, people, if this video helped you to understand, again, do not forget to like and also share this to your friends. We are done with 2.1. How about we go and do 2.2? All right, guys, here is our 2.2. Now, 2.2, we are also solving for x, but this time around it's logs. So we're going to use logs to solve for x because everything is given in logs here. So we have log base x 25 plus log base 3 27 minus log 10. All this is equaling to 4. So this question here, it might look tricky, but it's really not that tricky. So first of all, the first term here, log base x 25, just write it as it is, it's fine. So this one here, we can say log base x, right? We can write it like that. But let's look at the second term here. We have log base 3 27. This here we can write it as log, right, base 3, and then we have 3 to the power of 3. 3 to the power of 3, it's actually 27, guys, right? And then we say minus log 10. For now, let's leave it like that. All this is equaling to 4. Right. Now, let's start with the first term now. The first term, again, we leave it like this. We have log base x 25. There we go. Now, let's go to the second term. We have log base 3, 3 to the power of 3. Now, this one here, there is a law of logs where you have a log, let's say base a, and then b, then exponent, and then you can take this exponent n to the front. You can write this here as n log base a b. So what you did here, you just took the exponent and put it in front there. So as you can see, this 3 here, the one that I just highlighted is the exponent. So I can take it to the front. So let's do it. So we're going to have 3, right? Log base 3 3. Please do not confuse these. Be very careful. And then minus log 10. All this is equaling to 4. By the way, these are just laws for logs, guys, that I'm writing here. So as you can see, term 2 and term 3, they have something in common. There is a law that we need to apply for both of them. There is this law that goes like this. When you have log, right, a and the number there, it's a, this is going to give you 1. So if the base is a and also this number here, it's a, the answer is going to be 1. It doesn't matter as long as they mesh. If we use numbers, we can say log base 2 and then we have 2 there. This is going to give us 1, right? So look at this. We have log base 3 and 3 there. That is 1, right? Multiply by 3. So that is going to give us 3. So if you continue again, let's drop this log base x 25. There we go. And then we say plus. So we said 3, but what is log base 3 3? This is gonna be 1. I hope you can understand this part, guys. Right, minus. Let's go to the third term. Again, the third term is something that you need to know. It's a basic knowledge. I'm assuming you know it, but if you don't know it, I'm gonna try to remind you. Let's look at this one, negative log base 10. First of all, if the log doesn't display the base here, usually here, as you can see, these ones are displaying their bases, the first term the base is x, the second term the base is 3, but the third term they didn't write the base. So when the base is not written, just know that the base is actually 10 always. That doesn't change. This is similar to when you have a square root, guys, right? Square root of x. Just know that there is 2 there. We don't write that 2 because we assume that you guys know about that. There's a basics that you're supposed to know from primary school. All right, so similar vibes here. All right, let's look. We have log 10. So since they didn't write 10, the base is 10. Please don't forget. So as you can see, if we have log base 10 10, this is the same as this law here where you have the same base and the number there, right? If the number and the base are the same, they're going to give you 1. You see, we have the base of 2 and that is 2. This is going to be 1. So meaning we can write this as 1. All this is equaling to 4. I hope you understood. So the first term, let's just leave it as it is. We have log base x 25 plus, this is now is 3. 3 minus 1. What is 3 minus 1? 3 minus 1 is going to give us 2. All this is equaling to 4. Right. So let's create a bit of space here so that we can able to solve this further. Here's our space, guys. Now, if you continue here, we can transpose this 2 to the other side. We'll be left with log base x 25. This is going to be 4 minus 2. There we go. So log base x 25 is the same as 2. Right. So what to do here? How to convert from log to exponent, because we need to convert from log to exponent here. So how are we going to do this? First of all, when you convert from log to exponent, let me just write this. Or let's say from exponent to log. Let's start by exponent to log. So you have the base, right? And you have the exponent there. All this is equaling to, let's say, an answer then. So when you move from exponent to log, first of all, we're going to write log base. What is our base here? Our base is b. So the base is the same base for both exponent and logs, but the answer there, which is a, is going to come here. So we have log b a. All this is equaling to e, which is our exponent. So we need to change all of this into exponential notation. So let's go back using this rule here. So our base here, it's x. So we're going to write x there. As you can see, our base there, our base there, right? So it's x, right? Then our exponent, as you can see, our exponent, it's e. When it comes to exponent, our exponent there is going to be what? In our case, 2. Because this here is equivalent to exponent when you move to exponential expression. Now all this is going to be equaling to 25, because this a, it's supposed to be there, which is 25. Guys, I hope you can see this. It's very, very important for you to know this. So from here, we have to find x. So we square root both sides. So if you square root both sides, our x is going to be 5. So this here is our answer. So x is equaling to 5. So I hope you guys managed to understand this. If you didn't understand logs, then this was going to be challenging, especially the laws. Same thing with 2.1. You must know the laws of exponents and logs in order for you to understand this. I already done laws on exponents. Again, I left that video on the description and the icon on top there. If you go to the top right of this video, you will see I there. Click on that, and then you will see those videos. Right, people, if you have any questions, you can leave a comment asking your question. But before you do that, how about you watch the video at the point where you got lost, rewatch it. Probably you can able to understand it better. But if that doesn't work, please do not hesitate to leave a comment. But if this video helped you to understand better on how to solve for x using logs, do not forget to like and also share to your friends. If you haven't subscribed to the channel, subscribe to the channel so you'll get notified as soon as I upload those videos. All right, people, thank you very much for watching. We are done with question 2. It was short but yet exciting. So we are done with it. We will be doing question 3 on the next video. So at the end of this video, I will leave a playlist of this question paper and also the video of question 1 of this question paper. Thank you very much, guys, for watching. Till next time, cheers.